Hello everyone, welcome back to my channel Study With Me. Today I'm going to explain about Chemistry Standard Level Paper 2, November 2022. If you find this video is helpful for your exam preparation or revision, please don't forget to subscribe and let your other friend knows about my channel to support me. And let's get started. Chlorine undergoes many reactions. State the full electron configuration of the chlorine atom. Chlorine with the electron number of 17 has electron configuration of 1s2, 2s2, 2p6, 3s2, 3p, 5. State, giving a reason, whether the chlorine atom or the chloride ion has a larger radius. Chloride ion, Cl minus, the number of electron becomes 18. Okay, but chlorine atom, the number of electron, it's 17. So chloride ion has one extra electron, makes chloride ion has a larger radius as it has more repulsion between electron because it has one extra electrons for the chloride ion. Outline why the chlorine atom has a smaller atomic radius than the sulfur atom. For chlorine atom, it has 17 electron and 17 proton, and for sulfur, it has 16 electron and proton. So the electronic structure is 287 and 286. Even though it has the same number of shells, it has 3 shells here, both of them, but Cl has more proton, causing stronger attraction between electrons and protons. Thus, chlorine has a smaller atomic radius because it has more proton, so more attraction from the nucleus with the electron. So it squeezed the size of the atom, therefore the atom atomic radius becomes smaller. The mass spectrum of chlorine is shown. Outline the reason for the 2 peaks at 35 and 37. So 35, it's Cl, and then it's 37, so it means it has 2 isotopes, Cl35 and Cl37. Explain the present and relative abundance of the peak at 74. So this one at 74 here. Okay. 74, we can get it by 2 times 37. So 37, sorry, this one 35 and then 37. Okay, so 74, you can get it by 2 times 37. It means it has 2 Cl37, because you know Cl, it's not one atom, it should be a molecule. So it is Cl2 molecule with mass number Cl37. The least abundant isotope, as you can see on the picture, is very low. So the least abundant isotope. 2.67 gram of manganese oxide was added to 200 centimeter cube of 2 molar HCl. We've got molar and we've got volume and we've got mole of manganese oxide. The question is calculate manganese oxide, mole of manganese oxide. So to calculate mole, M divided by MR, 2.67 divided by molecular mass of manganese oxide, which is 86.94. You've got 0.0. Determine the limiting reactant showing your calculation. These are the reaction: MnO2 plus 4HCl produce Cl2 and 2H2O, MnCl2, the one that from here. Okay, I just copy it down. So MnO2 and HCl, which one is the limiting reactant? From the previous question, we can calculate mole of HCl because volume and concentrations are known. So N HCl, C times V, 2 molar times volume is 200 centimeter cube, so 0.2 decimeter cube, so it's 0.4. So here is 0.4 mole. Therefore here 1/4 times 0.4, it's 0.1. Okay, now which one is the limiting reactant? When we compare with the previous question, 2.67 gram of manganese oxide was added. So actually the mole of manganese oxide, it's 0.0307. So it's very small. Therefore, MnO2 is the limiting reactant. Determine the excess amount in mole of the other reactant. So MnO2 plus 4HCl produce Cl2, 2H2O, and MnCl2. As we know, the mole of MnO2 is 0.0307. So this is the limiting reactant. So now to calculate mole of HCl is 4 times 4 divided by 1 times 0.0307. You get 0.123. So we minus this, for mole of HCl, it's 0.4 after we calculate from here. So only 0.123 just now. 4 divided by 1 times 0.0307. This is the amount of HCl that is reacted when 0.0307 mole of MnO2 is added. So the excess would be 0.0277. You subtract this mole excess. Okay. Calculate the volume of chlorine in decimeter cube produced if the reaction is conducted at standard temperature and pressure. To calculate volume of Cl2, we need mole times Vm. And now we see on the reaction, Cl has the same coefficient with MnO2. Therefore, it has the same mole with MnO2. So it's 0.0307 times 22.7, which is 0.697 decimeter cube. State the oxidation state of manganese in MnO2 and MnCl2. So this is -4 because -2 times 2, so this will be +4, should be 0. So this +4, and this one -2 because Cl is -1 times 2, so this one is +2, so +2. Be careful, not 4 plus or 2 plus. You will not get a mark if you write it in that way. Deduce referring to oxidation states whether MnO2 is an oxidizing or reducing agent. Okay, oxidizing agent, it means experience reduction. Reducing agent, it means it experience oxidation. So MnO2 plus 4HCl produce Cl2, 2H2O and MnCl2. Mn here, the oxidation number is +2, and this one +4. We already calculated here. So +4 to +2, it's reduction. Therefore, oxidizing agent. It's always the opposite. If it's oxidizing agent, it's reduction. If it's reducing agent, it's oxidation. Chlorine gas reacts with water to produce hypochlorous acid and hydrochloric acid. Hypochlorous acid is considered a weak acid. Outline what is meant by the term weak acid. An acid that partially dissociate in water. Strong acid fully dissociates in water if it's strong acid. State the formula of the conjugate base of hypochlorous acid. So hypochlorous acid HClO, when it reacts with water, will produce H3O plus and ClO minus. So this donor or gives proton, so react as an acid. This is act as a base, and this one act as a conjugate acid, and this one conjugate base. So conjugate base of hypochloric acid, it's ClO. My conjugate base of hypochloric acid is ClO minus. Calculate the concentration of H plus aqueous in HClO solution with a pH 3.61. So H plus, it's 10 to the power negative pH, which is 10 to the power negative 3.61, which is 0.00025, or 2.5 times 10 to the power negative 4 mole per decimeter cube. State the type of reaction occurring when ethane reacts with chlorine to produce chloroethane. So ethane, CCH, react with Cl2. Okay, this Cl2 should split, produce a radical to chlorine radical. So then it will substitute one of the H and produce HCl. So the type of reaction would be free radical substitution. Okay, because this Cl2 needs to be split and produce chlorine radical, and directly substitute one of the H. That's why it's called free radical substitution. Predict, giving a reason, whether ethane or chloroethane is more reactive. Ethane has the bond CNH. Chloroethane has CNH, but we focus on more C and Cl. Okay, so the one that is more reactive, it's CCl, or I could say the answer is chloroethane, because CCl bond requires less energy, only 324 kilojoule per mole. So it requires less energy to break than CH, which is 414 kilojoule per mole. Bond in ethane. So to break CCl bond, is much easier compared to CH, because CCl requires only 324 compared to CH, which is 414 kilojoule per mole. Write the equation for the reaction of chloroethane with a dilute aqueous solution of sodium hydroxide. So chloroethane would be CH3CH2Cl liquid react with NaOH aqueous. So OH will substitute Cl, producing alcohol or ethanol. So that would be CH3CH2OH aqueous and NaCl. Deduce the nucleophile for this reaction in D3. So that would be OH minus or hydroxide ion. Ethoxyethane diethyl ether can be used as a solvent for this conversion. Draw the structural formula of ethoxyethane. So ethoxyethane, that would be CH3, CH2O, CH2, CH3. So ethoxy has 2C and ethane has 2C as well. So the structure would be deduce the number of signal of their chemical shift in the HNMR spectrum of ethoxyethane. So as you can see, here is symmetrical. So this CH3 and this CH3 will be the same. This CH2 and this CH2 also will be the same. So we have only two signals, okay? And then for the their chemical shift, so this one CH3, that would be 0.9 to 1 ppm, and then for CH2 would be 3.3 to 3.7 ppm. Let's check data booklet section 27. As you can see here, for CH3, it's 0.9 to 1 ppm, and why the CH2 is 3.3 to 3.7, because it attached to O and alkyl, like the structure O and alkyl. CCl2F2 is a common chlorofluorocarbon CFC. Calculate the percentage of by mass of chlorine in CCl2F2. So we've got 2 Cl. So to calculate mass of chlorine, percentage mass of chlorine, we do 2 times Ar chlorine, because we've got 2 chlorine, yeah, divided by Mr of CCl2F2. So 2 times 35.45 divided by 120.91 times 100, which is 58.64%. Comment on how international cooperation has contributed to the lowering of CFC emissions responsible for ozone depletion. So they do research collaboration for alternative technology to replace CFC, or they also do data to share, so they would be aware of what is actually caused by having CFC emission. You can choose one of them. CFCs produce chlorine radicals. Write 2 successive propagation steps to show how chlorine radicals catalyze the depletion of ozone. So propagation, when you produce the reactive molecule. So of course with Cl first, we've got chlorine radical. So then for the propagation, it will react with ozone, produce O2 and ClO radical. So the chlorine atom react with ozone, forming ClO radical that can further react with ozone molecule, cause depletion of ozone. So next, ClO radical will react with O radical, produce oxygen and Cl radical. The regeneration of Cl radical release also then go on to catalyze the breakdown of more ozone molecule. Okay, so these are the propagation steps, or if you don't want to write this one, you can also use or write ClO plus ozone will produce Cl radical plus 2O2. Both of them regenerate chlorine radical that will go on to catalyze the breakdown of more ozone molecule. So you produce, it keeps producing Cl radical, then it keeps reacting with ozone, produce ClO radical, and then the reaction keep going and keep going. Compound A is in equilibrium with compound B. Predict the electron domain and molecular geometries around the oxygen atom of molecule A using VSEPR. So OH, it has a lone pair, and this one with C. So it has 1, 2, 3, 4 domain. So it will be tetrahedral, and it has 2 lone pair. Therefore, the molecular geometry will be bent or V shape. The IR spectrum of one of the compounds is shown. You see here is around 1700 to 1750 centimeter to the power -1. So it's a C double bond O. Deduce giving a reason the compound producing this spectrum, the one that has C double bond O, it's B. So B, as it has C double bond O, absorption. Compound A and B are isomers. Draw 2 other structural isomers with the formula C3H6O. So 2 other structural isomers. So you need 2. We can do CH double bond CH OCH3. Okay, or you can also do CHHC double bond C HOH alcohol, or you can also do CH3 CH COH. Okay, so you can choose 2 of them. So one is ether and another one is with the alcohol, and then the other one is the carboxylic acid. The key here, you need to have double bond and then O, and the number of C should be 3, and then H should be 6, and then it has to have 1 O. The equilibrium constant Kc for the conversion A to B is 1 times 10 to the power 8. So K is bigger than 1. Deduce giving a reason which compound A or B is present in a greater concentration when equilibrium is reached. So Kc, if it's bigger than 1, it means concentration of product, it's bigger than concentration of reactant. Okay, B is the product. It means concentration of compound B bigger than concentration of compound A, because K is bigger than 1. If K is more than 1, then compound A or reactant is bigger than the concentration of product. An equation for the combustion of propane is given below. Determine the standard enthalpy change. Okay, so C3H8 and 5O2, 3CO2 and 4H2O. Then we can calculate here would be 8CH plus 2CC plus 5O, and so this CO R2 is 2, so it will be 6CO, and the same with OH, so 2 times 4, 8OH. So that would be 8 times 414 plus 2 times 346 plus 5 times 498. That's 6 times 804 plus 8 times 463. Okay, so you've got 6494 and this one 8528. So delta H 6494 8528, you've got negative 2344 2034 kilojoule. Calculate the standard enthalpy change delta H for this reaction using section 12 of the data booklet. So we need propane, oxygen is 0, CO2 gas and H2O gas. So we need propane and then H2O, but it should be gas, and then CO2. Okay, so delta HF for water but steam, it's negative 241.8, and for propane it's negative 105, and for CO2 gas negative 393.5. So delta HF is delta H product minus delta H reactant. So if we refer to this, that would be 4 times negative 241.8 plus 3 times negative 393.5, so 3CO2, minus propane, which is negative 105, and you will get negative 2443 kilojoule. Nickel catalyzes the conversion of propanone to propan-to-ol. Outline how a catalyst increases the rate of reaction. It provides an alternative pathway and lower deactivation energy. Explain why an increase in temperature increases the rate of reaction. Because when you increase the temperature, it will give more proportion of molecules with energy that is bigger or the same with activation energy, and this will cause greater frequency of molecules. Discuss referring to intermolecular forces present, the relative volatility of propanone and propan-to-ol. For propanone, as you can see the structure, okay, it has C double bond O, but for propantool, CH3, CH2, CH2, and OH. So in propanone, it exists dipole forces, but for propantool, it has hydrogen bond. Thus, propanol is less volatile due to hydrogen bonding is stronger than dipole forces. The diagram shows an unlabeled Voltaic cells for the reaction. Pb2 plus Ni produce Ni2 plus and Pb. Label the diagram with the species in the equation. Ni, nickel, is more reactive than Pb. Therefore, Ni will experience oxidation. Oxidation is at the anode. So Ni will be here, and Ni2 plus is the solution. Therefore, here is Pb, and this will be Pb2 plus. So here we'll have oxidation, and here it's reduction. Suggest a metal that could replace nickel in a new half cell and reverse the electron flow. In this case, we need to find a metal that is less reactive than lead. So let's see on the data booklet the reactivity series. So the metal that is less reactive than Pb, it has copper, and then Ag or Pd or Pt. So we can answer here. It could be Cu or Ag or Pd or mercury or platinum or Au, because they are all less reactive than lead. So you can choose one of them. Describe the bonding in metals. It's electrostatic attraction between a lattice of metal ions and a sea of delocalized electron. Nickel alloys are used in aircraft gas turbines. Suggest a physical property altered by the addition of another metal to nickel. Density or hardness or strength, because you know a metal that has a regular arrangement can slide over one another. Their layer can slide over one another, so it can be bent, or it can be hammered into a shape, or it can be drawn into a wire, which is ductile. But when you alter the physical properties by adding another metal, so now the structure is not a regular arrangement anymore. So the metal cannot slide over one another, as the size of atoms now are different. Therefore, it will increase the strength or hardness, or it's more dense. Okay, that's all for the explanation of the chemistry paper 2 standard level November 2020. If you find this video is helpful for your exam preparation or revision, please don't forget to subscribe and let the other friend knows about my channel. Thank you for watching, and bye.